Hello, we are from Group 65, consisting of me, Cindy, and then there is Phil and Colin, and we will be talking about our design implementation for the financial application.
So requirements for the project. For functional requirements, we've got multi-factor authentication, access control for financial data and servers, log records for database requests and key management, data encryption, and network monitoring. For non-functional requirements, we've got data backups, consistent and reliable uptime, dynamic scaling, auditable data, and reliable performance. For regulatory requirements, we've got the Privacy Act of 1988, the Consumer Data Rights, the Australian Corporations Act of 2001 and the APRA and the Australian Anti-Money Laundering Act.
For our final design, we decided to use a virtual private cloud. Here's a diagram representing the three main sections of our design. It contains the central financial service and database, the access control mechanism to a different part of the VPC, and the security and monitoring tools we employ. We decided on using the virtual private cloud because the cloud monitors the traditional network topology, allowing for familiarity with like previous existing tools and workflow, allowing for an ease of migration. It also employs scalable cloud services to dynamically handle traffic. And finally, our design allows for easy connection to other networks with the VPC peering connection, allowing for VPC and VPC connection, and a site-to-site VPN, allowing for VPC to traditional data center connection. To cover more in depth, we'll go over my section, network and database. Here, the section showcases some of the design decisions we decided for the VPC. The VPC requires access to the wider internet to perform its financial service function. This necessitates an internet gateway and a route table, which divert traffic through the internet gateway, and the route table divert traffic inside the VPC. To get the internet traffic to the internet gateway, we employ Route 53, which is a scalable Amazon DNS service, allowing us to respond to network traffic dynamically and scale to user needs. The VPC covers multiple availability regions. Each region contains a public and private subnet, as detailed in the diagram. Each subnet will be then hosting a financial service application and a financial database application, respectively. Access to the service and database are managed by security groups that encapsulate our region. This ensures proper user access to each of the service running on the subnets and will be detailed in the section by Collins. Next slide, please. All right. The financial service application is managed by an auto-scaling group. This group creates and deletes EC2 instances according to user demand from a minimum size to a maximum size. Incoming traffic to each instance is managed by an application load balancer. This distributed across multiple availability region to any healthy EC2 instance willing to take on the request. For our database, we decide to use the Amazon Relational Database Service, which is then encrypted at rest with the keys being stored in the KMS Key Management Service. This ensures that no data is stored in plain text and provide higher security for the data. We also employ the multi-AZ feature or multi-availability zone feature. This replicates the data from a primary database to secondary database stored in different availability zones with a very short delay. In case of a database failure, the secondary database could also act as like the primary database, ensuring that the service has a high uptime and that there's no single point of failure for the system. This improves resilience and ensures that the financial data have proper backup in multiple geographic locations. To recap, our system will provide a VPC, which allows for a similar environment to traditional database, a scalable financial service application, a secure primary database that has backup in multiple regions, and automatic failover to ensure high uptime for the critical financial service. We will then move into the access management part of our project.
Okay, so I'll be going over the implementation of access management components, focusing on how we can secure applications and data infrastructure in AWS. So firstly, we'll start with user identity and access management. To secure applications, we'll use Amazon Cognito, which integrates directly with AWS Identity and Access Management, or IAM, to control who can log in and what they can access. The process begins by creating an identity pool in Cognito. This pool allows us to authenticate users, whether they're administrators, developers, or auditors, and assign IAM roles based on their permissions. Finally, we will enforce multi-factor authentication, MFA, for all privileged accounts. This means that even if a password is compromised, a second verification step, like a code sent to a device, is required before access is granted. This setup greatly reduces the risk of unauthorized access. So, next slide, please. So next, we'll secure our VPC resources using security groups. The goal here is to make sure that only authorized traffic can reach our applications and databases. We'll start by creating an application security group named AppSG. For inbound rules, we'll allow HTTPS traffic on port 443 from anywhere so users can access the app. We'll also allow SSH access on port 22, but only from admin and developer IPs. For outbound rules, we'll restrict traffic so it only communicates with the database security group through the proper database port. Then we'll create a database security group called DBSG. For inbound rules, we'll only allow connections from the app SG. For outbound rules, we'll restrict responses so they only go to the app SG. This setup ensures that the database is never exposed to the public internet and only communicates with authorized application instances. Next slide, please. So moving on swiftly, we'll now talk about subnet design. We'll use two subnets to separate our application layer from our database layer. The public or application subnet using a CRDR block 10.0.1.0/20 will attach to the internet gateway, allowing user traffic to reach the application. The private or database subnet using 10.0.2.0/20 will not have direct internet access, and instead it will route outbound traffic only through the application subnet. We'll then be deploying our financial application instances in the public subnet and a database in the private subnet with the publicly accessible set to no. Finally, we'll be enforcing routing rules so that traffic flows only from the application subnet to the database subnet and not the other way around. Lastly, we'll be implementing strict access controls for our financial data subnets. This step ensures that only authorized applications and users can access sensitive financial information. We'll configure network ACLs on the database subnet to deny all inbound traffic except from the application subnet CRDR. We'll deny all outbound traffic except back to the application subnet. Within RDS settings, we'll enable IAM authentication, disable public access, and require SSL connections to encrypt data in transit. We'll then be assigning IAM roles to application instances, granting them only specific RDS access permissions that they need. Finally, we'll be storing all database credentials securely in AWS Secrets Manager to avoid hard coding any sensitive information. In conclusion, to summarize everything so far, Amazon Cognito secures user access and enforces MFA, security groups protect our VPC resources from unauthorized traffic, subnet separation isolates our application and database layers, and NACL's IAM roles and Secrets Manager ensure that only approved entities can access our financial data. And I'll be passing on to Cindy, who will finish this off.
Okay, so the next one will be the security and the monitoring. First of all, we have the CloudTrail and the CloudWatch. CloudTrail governs and record every account-related activities, including logging in, creating new roles, assessing resources, and others, making it perfect for monitoring actions for the AWS account. We can do this by creating a new trail, and it's also important to enable the CloudWatch as well to allows for the CloudTrail and the CloudWatch integrates with each other. And then it's also important to include the KMS and the network to make sure that it records every events in the account. The logs created from the CloudTrail will flow into the CloudWatch. The CloudWatch will present the metrics of the logs for better visibility. An alarm can be set up when certain conditions and activity happens to alert the user. This can be set it up by go to the log group and creating a new metric filter. And then by setting up a threshold, it will set up the SNS topic It will create a new alarm that will send an email to the user's email. The next one will be the AWS WAF and Shield. AWS Web Application Firewall or WAF can be used to monitor and filter incoming HTTP and HTTPS requests. They can be configured by using Web Access Control List or WebACL. More rules will offer more protection, but it will also cost more resources. Therefore, it is important to know the user's needs and budget before purchasing it. To create it, they will need to create a web ACL, and they can choose to either existing rules or they can create it from one. And then they will need to attach the web ACL to the AWS resources or to the CloudFront. AWS Shield is used to preventing the OOS attacks and is usually deployed together with AWS WAF. The standard version is free to use for the users and is automatically enabled. The advanced version offers more robust protection but must be purchased first. The next one is the AWS Network Firewall. It monitors the network traffic and filters them for the AWS VPCs. It is used for creating and managing the firewalls of the VPCs, creating the user control of the network and the traffic of VPC. It first needs to create a rule group and choose to be either a stateless or a stateful rule group. And then once the rule group has been created, the user will need to create a firewall policy and then attach the rule group to that. The policy then can be attached to a firewall, and then you need to update the VPC route tables and direct the traffic through the firewall. The next one is the Guard Duty. Guard Duty continuously monitors and analyzes the logs and data sources to detect any anomalies and malicious activities. It could integrate with other AWS security services and support multi-account environment for easier management and monitoring. First thing first, you need to enable the Guard Duty first, and then generate a sample findings and archive it. And then these findings could be configured to a S3 bucket, and then you can set it up with SNS to set up the alerts and send it to the user email as well. So basically, yeah, that's all about our presentation. Thank you.